Hi everybody, Mrs. Pesic here. This is your Blended Learning Day assignment for geometry. This is section 12.7 in your book called Circles in the Coordinate Plane. So let's learn about circles and what they are and how to write equations for them. So a circle is the set of all points that are equidistant from a given point. So in this case, if we have a circle that we have center of A, then all the points on the circle are going to be the same distance from that point A. Circles are named using this symbol here and its center point. So we would call this circle A using that symbol. That means that the circle has center A, and what would the radius be? Well, we could look at the picture and we could say, hey, the radius is this segment that's going from the center out to a point. So one radius would be segment AB. All right. We could say that that segment AC is also a radius, or we could say that AD or segment AD is a radius. Those would all be examples of radius. But if you go all the way from C to D, all the way across, then that's not a radius anymore. Segment CD would be a diameter of the circle. All right, so let's move on. So the equation of a circle is given by x minus h quantity squared plus y minus k quantity squared equaling r squared. Well, the h and the k that you see in the formula right here and right here are actually the coordinates of the center of the circle. And r is the radius, so this part of the equation has the radius squared. So let's see how to use this formula. So just a quick example. So if I say x minus 7 quantity squared plus y minus 1 quantity squared equals 9, then we can see that the center of the circle is going to be what? Well, remember, we're looking for the h and the k, and the formula says x minus h, so in this case it's x minus 7, so this 7 is the x coordinate of the center, and I see y minus 1, so this 1 is going to be the y coordinate of the center of the circle. And so what's the radius going to be? Well, the radius is going to be the square root of this number. So the radius is going to be square root of 9, which is equal to 3. And to get a little visual of this, we could draw a sketch of this circle that we have here. And we draw a sketch of this. Quick little sketch here. Just like this here. So this circle is going to have its center at 7, 1. Here's 7, 1 right here. And from that center, it's going to have a radius of 3. So it's going to go up 3, it's going to go to the right 3. I'm a little bit off my graph. Down 3 and left 3. And so we're talking about the circle that looks like this. Let's take a look at another example. This time it says write the equation of the circle A, that has center 4, negative 2, and a radius of 3. So again, we want to use the form x minus h quantity squared plus y minus k quantity squared equaling r squared. This is the standard form for the equation of a circle. If you know the center is 4, negative 2, that tells you that your h is equal to 4 and your k is equal to negative 2. So let's plug those in. So we're going to have x minus 4 quantity squared plus y minus our k, but the k is actually negative 2. So I need to have y minus a negative 2 squared equaling, and the radius is 3, so I'm going to have 3 squared. So that means my equation could be written x minus 4 quantity squared plus y plus 2 quantity squared equaling 9. Okay, let's take a look at another example. This one says write the equation of the circle. We want circle B. We want it to pass through the point -2, 6, and we want it to have a center of 6, 3. So let's kind of get a visual of what's going on here. We want the center to be at -6, 3. That would be right here. So this is point B. That's the center of our circle. And we want it to pass through -2, 6. So we want it to go through this point. So if you're getting a kind of a visual of what we're talking about, we're trying to get the equation of a circle that looks something like this. So how are we going to do that? Well, we already know the center, and that means that this -6 is going to be our H, and the 3 is going to be our K, because the center of the circle gives us our H and our K. So we do know that the formula is going to be remember it's x minus h quantity squared plus y minus k quantity squared equaling r squared. So for this problem, we can say x minus our h, so that's going to be x minus a -6 quantity squared plus y minus, our k value is 3, so y minus 3 quantity squared equaling r squared. And so that's going to give us x plus 6, because minus -6 is x plus 6, quantity squared plus y minus 3 quantity squared equaling r squared. So we're almost done with our equation, but we do need to find the radius of the circle. And in order to find the radius of the circle, we're going to have to find the distance from that center out to this point right here. So remember, they only told us one point on the circle, and that's right here at -2, 6. So we really need the distance from the center, which is -6, 3, out to a point on the circle that's -2, 6. All right, this kind of problem shows up on the ACT often. So let's do this. We're going to have to find the distance. Remember, here's our distance formula right here. So let me bring that down so we can work with that. And we're trying to find the distance between these points. Let's call the -6, 3 our x1, y1. And we can call -2, 6 our x2, y2. So using our formula, we're going to say that the distance between those 2 points is going to be x2 minus x1 is going to be -2 minus a -6 quantity squared plus, we want the difference in the y, so 6 minus 3 quantity squared. And so that's going to give us -2 plus a +6, that's going to be 4 squared, and then 6 minus 3 is 3, so I get 3 squared. And so that's going to give me the square root of 16 plus 9. And that's equal to the square root of 25. And we know that that's equal to 5. So that means that this distance between these 2 points is equal to 5 right here. Okay, if that's 5 units, you know that that's also the radius of our circle. That means I can fill that in for r. So the radius is 5. So in our equation that we had all set up right here, it was all done except we didn't know what the radius was. But now we do, so we can plug that in for r. So our final equation should be x plus 6 quantity squared plus y minus 3 quantity squared equals 5 squared. Or we could write it x plus 6 quantity squared plus y minus 3 quantity squared equals 25. And that'll be our answer for this problem. Let's take a look at another example. Here it says identify the center and the radius. We see x plus 4 quantity squared plus y minus 3 quantity squared equals 1. Again, the general form is x minus h quantity squared plus y minus k quantity squared equaling the radius squared. So if I see that x plus 4 is equal to the x minus h, I can subtract x from both sides, and I get that 4 is equal to -h. but I don't want negative h, I want positive h, so I'm going to just multiply both sides by a negative 1, and then I'll see that h is really equal to negative 4. So my center, remember center is hk, so far I know that my center is negative 4 comma something. And here I see that the y minus 3 part, that's going to be our y minus k. So if y minus 3 is equal to y minus k, then I can subtract 3, or I can just notice that the 3 must be equal to the k. So if k is equal to 3, then my center is negative 4, 3. What about the radius? Well, I see that the radius squared is equal to 1. So if r squared is equal to 1, I need to take the square root of both sides, and technically that's plus or minus, but we'll just assume that our radius is positive. So the square root of 1 is 1, so the radius is just 1. Let's take a look at another example. Here it says, use the graph to write the equation of the circle. So this time we're not told any point specifically, but we can look at the graph to figure some things out. So it looks to me like the center of the circle is at what ordered pair? Looks like it's right here, and that ordered pair would be 4, 4. So 4, 4 is the center of the circle, and I'll just call that point C for the center. So the center is 4, 4. And now we need to find out what the radius is. Well, you can go from the center to any point on the circle to get the radius, but it's easiest if you just go, horizontally or vertically. So let's just go straight down to get to a point on the circle. And so this means this is going to be our radius, r. And it looks like I went from 4, 4 down to the order pair 4, 2. And so that's a distance of 2. So the radius is 2 units. So now that we know the radius is 2 and the center is 4, 4, we can write the equation. Remember, our general form is x plus h quantity squared plus y minus k quantity squared equals radius squared. We are plugging in 4 for the h and coincidentally 4 for k. So I'm going to plug in 4 here and 4 here, and I know that the radius is 2, so I'm going to plug in 2 for the r right here. So my equation should be x minus 4 quantity squared plus y minus 4 quantity squared equaling 2 squared, and we can square the 2 and get 4. So the equation of the graph that we see here is really this circle, x minus 4 quantity squared plus y minus 4 quantity squared equaling 4. That's the equation for that circle. Let's take a look at another example. Here it says write the equation of the circle, circle D, with center negative 3, negative 6, and a radius of 4. So again, we could get a visual of what's going on here. If we would like, you can see visualize this circle. So we're talking about a circle that has a center at negative 3, negative 6. So here's my center. I'll call it D because they called it circle D, so that means the center is D. And I have a radius of 4, which means I want to go up 4, 1, 2, 3, 4, and over 4, 1, 2, 3, 4. Down 4, I'm going to be a little bit off the grid, 1, 2, 3, 4 to the right. So basically, the graph of this circle would look something like this. And we're trying to find the equation of that circle. In general, the equation is x minus h quantity squared plus y minus k quantity squared equaling radius squared. And so if you're noticing, the h is negative 3 and the k is negative 6 because the center gives us our h and our k. So we're going to plug in negative 3 for the h and negative 6 for the k. So in this case, we have x minus a negative 3 quantity squared plus y minus, our k value is negative 6 quantity squared equaling, and I can plug in our radius of 4, right, for the r, and so I have equals 4 squared. All right, and we can simplify this equation by writing x minus a negative 3 is x plus 3 quantity squared, y minus a negative 6 is y plus 6 quantity squared equals 16. So this is the equation for this circle. Let's take a look at another example. In this case, we are just asked to identify the center and the radius of the given circle. So again, if we know that the formula is x minus h quantity squared plus y minus k quantity squared equaling r squared, our equation has a 1 right where the h is, right? Because the x minus 1 is equal to the x minus h part. So that means that h must equal 1. Remember, our center is hk, so in this case, that's going to be 1 comma what? Well, we just have y squared. If it's just y squared, then how are we going to find the k? Well, think of the y squared as really y minus 0 quantity squared, and so that means that the k value must equal 0, because it's really y minus 0 quantity squared. So our center is at 1 comma 0. How about the radius? Well, remember, this number right here is the radius squared. So if 16 is equal to the radius squared, we're going to take the square root to find the radius. Take the square root of both sides, and we find out that the radius is really the square root of 16, which is 4. Let's take a look at this next example. So over here, we see that the formula for this circle is x plus 4 quantity squared plus y plus 4 quantity squared equals 12. And we're asked to find the center and the radius. So if our formula is x minus h quantity squared plus y minus k quantity squared equaling r squared, then that says that the x plus 4 must be equal to the x minus h. And if we're trying to solve for h, we could just subtract x from both sides, and we would get 4 is equal to negative h. But we really want to know what h is, not negative h. So we could divide both sides by a negative 1, and we would get negative 4 is equal to h. So that means that my center, remember the center is the h comma k, so my center would be negative 4 comma something, and we would want to do the same thing to find k. We know that the y plus 4 here has to be equal to the y minus k. So I can set y plus 4 equal to y minus k, subtract y from both sides, and I would get 4 is equal to negative k. Divide both sides by negative 1 to get k by itself, and we get that k is equal to negative 4. So my center is negative 4, negative 4. What about the radius? If 12 is the radius squared, I can write that down. R squared is equal to 12, and then I need to take the square root of both sides. Technically it'd be plus or minus, but we're not worrying about that because we're not going to have a negative radius length. And so when I take the square root of r squared, that's just r. And I can simplify square root of 12 because that splits up into square root of 4 times 3, which is square root of 4 times square root of 3. And square root of 4 is equal to 2. So I really could write my radius as 2 times the square root of 3. So that's the radius of this circle, because r squared is equal to 12. Our radius is 2 times the square root of 3. Let's take a look at another example. Here, you're asked to use the graph to write the equation of the circle. So let's find the center first. The center looks like it is 1, 2, 3, 4 units to the left, and 1, 2, 3 units down. So this center, I'll call it C for center, and that ordered pair is negative 4, comma, negative 3. Well, that tells me what my h is in my equation and what my k is. The center is always hk. So our model is x minus h, quantity squared, plus y minus k, quantity squared, equaling r squared. And so I know what to plug in for the h and the k, so I'm going to write x minus a negative 4, quantity squared, plus y minus negative 3, quantity squared, equaling r squared. But we didn't figure out the radius yet. Can you tell what the radius is? We want to go from the center of the circle out to any point on the circle. So one idea is to just go to the left and see that we're actually hitting here at the order pair -7, -3. That's this point right here. Well, that was 3 units from -4, -3, so it sure looks like the radius is 3. So I'm going to plug in 3 for r, and that means I'm going to have x minus a -4 is x plus 4, quantity squared, y minus a -3 is y plus 3, quantity squared equaling 3 squared. I'll write that out, equals 3 squared, which is 9. So my final answer for this problem is going to be x plus 4 quantity squared plus y plus 3 quantity squared equaling 9. And that's the equation of that circle that's graphed there. All right, let's take a look at this example. It says use the given information to write the equation of the circle. The center of the circle is 3, -16. So that means that 3, -16 is going to be our hk. So h is equal to 3, k is equal to -16. All right, and so far we know that the model is x minus h quantity squared plus y minus k quantity squared equaling the radius squared. So I can plug in the 3 for h, so I've got x minus 3 quantity squared, and I can plug in, I have my color coding, so I'm doing x minus 3 quantity squared plus y minus my k value is -16, whoops, quantity squared, and that's going to equal r squared. Well, okay, that's going to be x plus 3 quantity squared. No, it's not. It's going to be x minus 3 quantity squared plus y plus 16 quantity squared. So it's x minus 3, but it's y plus 16 equaling the radius squared. Looks like we're almost done, except we need to find the radius to plug in right here. So we need to find the distance from the center to this point on the circle. So let's use the distance formula. We're trying to find the distance from 3, -16, which is our center. Let's call that x1, y1. And the point on the circle is 1, -14. Let's call that x2, y2. We're trying to find the distance between these 2 points. So we're going to use that distance formula, which is x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So plugging these values in, we're going to have square root of 1 minus 3, that's our x2 minus x1 quantity squared, and then -14 minus a -16 quantity squared. So here we have -2 quantity squared. Make sure that -2 is in parentheses before you square it. And here we've got -14 plus a positive 16 is going to be 2 squared. And when we work that out, we end up getting -2 times -2 is 4. 2 times 2 is 4. Excuse me. So we're getting square root of 8. All right, and so that means that's the distance between those 2 points, but that also means that square root of 8 must be our radius. So if the radius is square root of 8, we just need to plug that in for our r right here. So in goes square root of 8. So our equation is going to be x minus 3 quantity squared plus y plus 16 quantity squared equaling square root of 8 squared. Well, square root of 8 squared is square root of 64, which is just 8. So our final answer for this problem should be x minus 3 quantity squared plus y plus 16 quantity squared equaling regular 8, not square root of 8. Because square root of 8 squared is 8. Okay, so that's it for this video. What's next? You're going to do your practice worksheet and you're going to check your answers. You're going to go back and you're going to re-watch any parts of this video that you are unclear about. And then you're going to take the quiz that's on Blackboard. You get 2 attempts at this quiz, and your overall scores, the 2 scores, will be averaged together to give you your quiz score for this blended learning assignment. All right? So don't wait until the last minute. The quizzes will not be reopened for any reason, so make sure you get it done on time. And thanks for watching.